Everybody. Appreciate you all attending. And I first again apologize once again for not turning my camera on. I'm having difficulty with my internet connection, and it seems when the video is on, the connection's weaker. But I do want to take this opportunity to thank Dr. Erdell Maurice for coming to and uh, substituting today for and to present a very, very important presentation, I think. It's so important for us to move forward in the world of artificial intelligence, to move forward with preparing our not only our university students, our college students, our community college students, but also our pre-college students. And when we talk about pre-college students, we talk about artificial intelligence, we really need to get down into the middle schools. Artificial intelligence is, based upon data science and engineering. And that data science and engineering, which fosters artificial intelligence, and you've heard about machine learning and deep learning, all of that. Well, data science is about discrete mathematics. And this, the National Science Foundation has been telling people how important discrete mathematics is. They've been telling people this for the last 30 years, even set up a very, very well-known science, multi-million dollar science and technology center at Rutgers University. And that center is called the Discrete Mathematics for Advanced Computer Science. So you hear it's even important in computer science. But very little has been done in our pre-college curriculum about advancing mathematics, and that lays the foundation, part of the foundation for artificial intelligence and data science. We're very, very interested in having our very own developmental research school, our very own Florida A&M developmental research school, help lead the nation. This is happening at other pre-college curricula across the country. In particular, the state of California has actually designated a one of their schools as an AI pre-college school. So I'm now going to turn this over. I'm excited about Dr. Erdal Maurice telling you what our grant, the Connecting Minorities Communities grant, has been doing by engaging faculty from our College of Education and our Developmental Research School as they've prepared modules and worked together with both the superintendent and principal of the Developmental Research School to build this foundation. And so, Dr. Maurice, I turned it over to you.
All right. Good afternoon, everyone. I hope everyone had a lovely weekend. As you know, we're starting to turn our eyes towards Thanksgiving. Just thank you for all for coming by. I would like to start with a little bit of an advertisement, I think. Where did it go? Where did it go? First, we just want to remind everybody that on Wednesdays, we also have introduction to generative AI sessions. Those are at 4 o'clock. The web address is slightly different. Dr. Lu will be presenting this Wednesday. So you don't keep that in mind. You know, you're trying to spread the word. So there we go. All right, so designing AI curriculum for middle school. Um, working at Family Development Research School. All right, so let's give ourselves a little bit of a background right here. Um, all of this can kind of say has a root starting with data science. Data science right here, you have this lovely pictograph from the Viterbi School at University of Southern California. And you can see right here, data science right here basically wraps around the idea of managing large amounts of data. They have the idea of big data, um, data wrapping, visualization, communication. And then within the data science, right here, you have machine learning, where we're teaching algorithms to try and help us make predictions. And then we have the larger field of artificial intelligence. Well, not larger field, the newer field of artificial intelligence using deep learning right here. But the key thing right here is first and foremost, data science touches on statistics and mathematics, data systems, high performance computing, Internet of Things, security and privacy, as well as language processing, cognitive science, robotics, ethics. And even also as important is that data science touches on so many, in fact, all of our areas, social sciences, natural sciences, health sciences, and engineering. This field is exploding, but more importantly, this field is leading to a lot of new pathways of learning, a lot of new avenues for us to explore. And so, because of this right here, that led us to the simple question of when should we start, or how should we engage our students in learning about these things? I have a different perspective I wanted to show as well. A different way to look at data science right here is looking at it in certain categories. Data visualization, putting taking huge amounts of data and having ways so we can see and understand it. One of the big things is statistics. For example, in the middle school, it takes a while for students actually start seeing any amount or any kind of statistics, communication. From the academic standpoint, people who know about the stuff have to have ways to communicate these with individuals who are not necessarily within the field. You get your machine learning, touching on a second, business. This thing right here, right now, is huge in business. So many businesses are just trying to understand how do you use robotics, how do you use these AI chatbots to improve efficiency. How do you teach their current employees to use these things and how to make decisions about how to use them? Of course, you have computing. And along with computing, you have these several languages that you need to learn. Python right now is the one of the main languages used for data science and artificial intelligence. And one of the key things right here is that problem solving, teamwork, learning, critical thinking, curiosity, all of these things are concepts and ideas that we have to start to develop in our students as we start getting them ready for this AI job workforce, and as we get ready to study and learn about AI. Ethics right now is something that I might say is a little bit lacking. We really have to come up with thoughts and ideas, regulations, rules, concepts, ways for teams and people to work together using these tools. Right now in art industry, for example, there's lots of back and forth between who owns what material and what material can be used when and how. Sora had several issues with that, and so they're working those things out. And of course, there's fundamental mathematics are the heart of all of these things right here. You were just saying about discrete mathematics is at the center of a lot of these applications and tools that we're using. And one of the biggest uses right now is natural language processing, the ability to process the human language to help us to work, understand, and learn within our natural environment is key to all of these advances that we have seen so far. Yeah, but, all right. So, what's machine learning? Machine learning is us taking our statistical algorithms and pushing them to the edge. Most of the statistical algorithms we learned in high school, our early college courses, those algorithms can actually be used. What has happened is we've simply taken those applications and thrown tons and tons and tons of data at them. And what has to happen was those applications have had to be redesigned to handle large amounts of data. But the key thing right here is that we found that with those, you can make generalizations to new unseen patterns within the data. And so that's what we call right here machine learning. Examples are multivariate regression. Like I said, we've all, I don't know all, but hopefully some of us have come across regression, trying to fit things to a line. And multivariate regression is we're trying to fit to a line where we have several variables that we're applying. And then decision trees. You have an example of a decision tree over here, where basically you have questions and the questions split based upon the data. And we can use that to kind of figure out the answer people are going to give to a question or to a problem that we have. And then we have deep learning and artificial intelligence. Deep learning right now is something called the neural network process right here. And it is still called this, although not as much in this day because we're starting to understand what's happening. But the neural network has often been branded as what we call a black box solution. In this right here, we just feed data. And what happens is that data goes into what's called the hidden layers, neurons that are connected to each other. And then that hidden data gives us an output prediction. And initially, it just seemed to work like magic. But now, because we want to understand, we've kind of sat down and thought about how exactly to design these things to try and figure out, explain the steps that the neural network is doing to try and figure out the answers. And it's interesting when you start doing that and kind of see how neural networks show patterns of quote unquote thinking as the data goes from one edge of the neuron all the way through the system. Remember, these systems now have trillions of neurons in them. They were initially trying to mimic the human brain, and that's why the idea is right here is deep learning, is that as information passes from the inputs and through the hidden layers, they have been able to observe quote unquote thinking processes where certain data is held on while other data is acted upon, and then data is recombined, and then that's acted upon to come up with a conclusion uh, or a prediction. And so that's what we call that deep learning. And so the question is, why teach middle school students this kind of information? Well, this right here is a new, innovative, and rapidly growing field. Literally, we're at just the beginning of this field. And so we will need the next generation to, one, be able to use these tools, but two, the next generation be able to create the next steps and the next variations on these systems. Um, they provide a new and different entry point into STEM careers. The hard fields, chemistry, physics, mathematics, um, those fields right here have often been, many have had many stumbling blocks for students. But this right here may provide a different way to get into the STEM field. Um, there are right now a lot of high paying jobs in this field. And a lot of them, you may not even need to do a lot of calculus, high level mathematics to actually get into these fields. And then students, if they get started now on their training, it'll be easier for them to get absorbed into industry when they make those next steps. Also, we want to keep in mind is that we want to have students to have that choice whether they want to go into industry or academia. And so we want to start them out with those fundamentals to help push them in the right direction. The key thing, though, is at the middle school. Remember, in elementary school, the focus right there is on learning the foundations of math, reading, and writing. And so in elementary school, you're focused on your basic operations, you're focusing on understanding how you convert those into sentences, how to write, punctuation, that kind of thing. And so elementary school may not have been the best entry point, but in the middle school, when students start to do more analysis, just getting their feet wet and trying to understand how different aspects of information can be fit together, we may have some areas where we can start applying or teaching the students about AI and data science. All right. So the thing is, AI is already in use, and we are entering a world where new normal might be strange for some of us older people. Students right now are using AI at home. They're using generative AI to give them immediate feedback and give them intelligent tutoring systems. We just had a presentation in the math department about this thing called Circle In. I don't know how many students are using it, but Circle In, their big new first right now is a intelligent AI tutoring system. Literally, their research shows that students are now studying at 3 a.m. in the morning, and almost none of the services that we provide are available at 3 a.m. in the morning. But these AI tools can be used 24/7. On the other hand, teachers are also using artificial intelligence. They're using it to help create lesson planning, creating notes. Some of the systems, like my math lab, have AI grading assistants within them, helping them to find new materials for class and helping them to create assignments. And so what happens right here is our current curricula have virtually no artificial intelligence in them. But we're seeing this strange new normal where everyone is using artificial intelligence. So the question is, why are we ignoring it? Why are we not redesigning, rethinking our curriculum so that we can take advantage of the resource that is artificial intelligence, machine learning, data science? And so that takes us to our strategic gap that we are trying to fill, questions we're trying to answer. So we have this current state. Students, teachers, administration of schools right here, they're using the AI tools for efficiency. But the question is, who is teaching students the fundamentals of artificial intelligence, machine learning, and data science? How do these things work? Why do these things work? How does one go about creating these things? What does data science mean? And what is a large data set, right? And then how are we getting ready for research in these fields? How does one understand the foundations, the fundamentals, and then what are the next steps and what are the next questions that one has to ask so that we can try to get answers to those questions? And then there is responsibility and using these things ethically. How do we train our students to use these things wisely so that they don't become a crutch? Instead, they become a powerful tool that will allow them to be efficient in their learning, be ready for the next step, and be able to help push society in the right direction. And so that's the kind of the gap that we're seeing right now. And that's why we felt that there's an emergent need to start the process of retooling these curricula to try and get ourselves to a space where we are better balanced in using these tools. The foundation framework that we're going to use right here is something called a universal design for learning. And the universal design for learning right here has three major components. That is engagement, understanding the why of learning, leveraging students' interest to help them work hard at what they're doing, representation, giving various visuals, ideas, ways of accessing and understanding the information, and then action. Examples, creating products, doing projects, uh, doing research, different ways to try and express and show that you're learning. And so what happens right here is we use this right here to create several what we call mini curricula. Um, Currently, in the way that most curriculums are set up right here is that they're mainly driven by legislation, i.e., there is a legal set of information that needs to be covered. Um, the classic statement right here is that the curriculum is a mile wide and an inch deep. And so what happens, the curricula tends to cover a lot of information, but not that in depth. But that leaves us with a basic problem in that there's not much space right now in the current curriculum. And so, there are two ways to work on that problem. One, there is a top-down way of working on that problem where you would go to the legislature and say, hey, we need more AI in the curriculum, and then have them legislate, make changes to the curriculum, and then push those down. But the other way is a bottom-up process where we let teachers, where we let lecturers, instructors, professors look at the needs of their students and create items that will then meet the students where they're at. We decided to go with the second format. And so what happened is we had a mixture of professors from Florida A&M University and teachers from the FAMU DRS come together and collaborate, learn more about data science, and then to use that to create we call that mini lesson plans to kind of help start engaging students in all of this lovely material. So let me show you a few examples of these of these. Let me share a few examples of these. I have one right here. This is a small lesson plan right here on ethics in data science. This right here is the idea of identifying privacy, accountability, transparency, fairness, bias, what is responsible AI, and safety. And basically break the students up into groups and have the students research, talk amongst each other about what they have, and then presents to the class the information that they learned from their research. Um, the idea right here is that to get students to start thinking about artificial intelligence not simply as a tool, but simply think of it as a process, and that it's not just, hey, I got this information, I can just keep this information, I can just use it. However, this is actually a source, and so we have to treat this source with respect. One, how our information is given to the tools, because a lot of students, for example, don't know that a lot of the information you type in there becomes property of the company, but also how these tools can be biased and how to use these tools safely. There are several negative side effects that we don't hear about, we don't talk about when it comes to these tools. Here is a plan on engineering. So this right here was an engineering one that we worked on, and what happened was they just added in AI engineering. And so again, it's still middle school, and so they just had to look up different engineering disciplines, history of engineering. Again, just trying to understand what um, we need to become an engineer, important skills, and ways to design and build ideas and concepts, and not just things. Because there are many different kinds of engineers in there, and so you have one right here on this right here. You have one on mathematics right here, And so this one right here was add, subtract, multiply, divide positive rational numbers. Again, as you'll see in a little bit, for us to do a little bit of the data science, we need to have a fundamental understanding of mathematical background. And so this one right here is geared towards teaching students about real numbers. This one is a 2 plus 3. Um, I do not know how much you know about neural networks, but neural networks right here come from the basics of something called node science. Um, and the basic way that a neural network works right here is that there's an input coming into the neural network. What happens is that the neural network processes the input and then pushes out several outputs. Um, in this example right here, we have a transformation object, i.e. your neural network, your neuron rather, and then you have an input coming in, and with that input, you can create several different outputs. And so again, this right here is to just give students an idea of what a neural network is and what it's doing. And then that's followed up by second example, um, where we're switching this from we're switching this from what I'm looking for from physical to numbers. And so what happens right here is you have this component A, B, C, and D. These are all neurons, and each neuron does something specific. In this example, you multiply by 2 and then add 5. And so if I'm starting to number 0, that becomes my first input. That input gets passed to neuron B. Neuron B then passes an input to neuron C, and then that input gets passed out, and that becomes my output. Literally speaking, those fancy AI machines, that's literally all they're doing. Each neuron simply has two numbers in there, one number to multiply and one number to shift up and down. And literally, they're just doing millions of these calculations. And what happens is that the outputs get spread amongst several neurons, and then those get pushed all the way through. It's really fun to see when you can actually see how these chain results together right here. But again, the idea right here is we're trying to create real world scenarios where students have to think through a process of, okay, I'm going to start with a number, but I have to make adjustments to that number. And when I get an output, I have to kind of think about what's the meaning of this output. And so we have this lesson plan right here. Uh, And then I have this last one right here. There are several of them. I don't have time to share it all. But this one right here is to teach about machine learning, and this one here about trees, sub-area statistics. And so basically what happens right here, this is what a set of data might look like. And then what happens is a tree, like I showed at the beginning, can be shown as a, a set uh, of splitting apart decisions. But trees can also be seen as a two-dimensional field that has been slowly broken apart into smaller and smaller squares. And so basically, this is my data in the real world. Instead of just these few dots, there'll be billions of dots in here. And what happens right here is the tree is basically saying, hey, if the person scores between 2 and 3 on this feature, and then they score between 1 and 2 on this feature, then this might be a suitable output for what that person might do on the question at hand. And so basically in this one right here, we give students paper and literally a ruler and just have them divide up this space right here into different regions. And then we can then ask them, say, hey, let's say a vehicle has X displacement and X miles per hour right here. Can you give me a price for the vehicle? Can you give me a price for the vehicle? So here we go. This is an example of displacement versus MPG. So if I give you a displacement, can you estimate what the mile per gallon for the vehicle is? And so if I say the MPG, the displacement on the vehicle is almost 400, right? You can make a estimate for that the displace the miles per gallon be at 15 miles an hour. 15. You can do these kind of things right here. Teach students how to break the data up and to can understand what kind of decisions are being made. All right. So the key thing, however, is to notice right here is that this data science right here is a huge field. There's so many areas that we can go in. There's so many areas that we can go in to show students start building that foundational knowledge for students. And so if they go into a job and they have to use a large language model, for example, to give them text. I know there's this one about this person who was responding to people's complaints. And it used to be that she would be able to do maybe one letter an hour or so, one letter every 20 minutes or so. But if AI, she would do one letter every 5 minutes. And so, but understand the nuances of why I have to structure my input this way. Why, when I get an output, I can't just simply take that output and send it out the door. I have to think about the ethics, about the kind of reply, about the fact that the machine might be making a mistake. But also, if a student wants to go into academia, we start them getting down that road of understand, okay, this is what a neural network is. Okay, this is what a tree is. Hmm. People have been using trees for all these years, but there are some areas where trees don't work well. Can we develop a new way of processing or creating our trees to help it to work in that area? And so there's lots of opportunities for us as students to grow. So at this point right here is where I'm going to pause for a while and make this a little bit interactive. I have some questions right here that I think that we all should try to answer. And so I'm going to give you about 5 minutes or so to pick maybe one or two of these questions and see if you can just write down a short answer a few ideas. And then we can see if we can kind of talk about those ideas and see if we can, get that process started of us thinking about um, teaching AI. So the first question is, why is it important to start introducing artificial intelligence to students at a young age? How do we teach students to use tools without relying on them? Is AI the new calculator, or is it something more? Um, how do we educate teachers on this new curriculum? Because a lot of us teachers do not have, when they went to college and middle school and high school, AI thing didn't exist. And then, do we need a new citation methodology for AI tools? Students are using these things every day. How do we monitor? How do we help students clarify when and how to use these things? So again, you can pick one of these questions. So you can write down an answer. And then you can do one or two things. You can pop in and say, or you can just put it in the chat and then I can read it. And then, we can talk about these things for a few minutes.
Yeah, I think that's a great idea, Erdell. Generate this discussion. Those are very, very significant questions. Glad to see them. I really appreciate you putting them up there. So let me ask the participants, please put your thoughts in. You want it in the chat, correct, Erdell?
Uh, yes, please.
Yeah. Please put your thoughts in the chat and let's see how we generate a conversation. This is fundamental. This is really getting to the grassroots of where our educational system will be going and needs to be going. Okay. None of this is going to go away. It's only going to get bigger and bigger. Okay. So please put your comments in.
One of the things they teach us in teacher school is that the uncomfortable silence. Teachers like to talk, but
What's
you just
that?
have to wait. And the uncomfortable silence.
I know. Don't be,
But
there's nothing wrong with it. Listen, every question's a good question. There's no bad questions. There's no bad input. You've got to remember that. Um, Matter of fact, there's a very famous saying. I bet you all know who has said it, but our life begins to end if we don't speak up. Okay. I paraphrased it, but anyway. So yes, speak up. This is a discussion that we're starting here, but it's a national discussion. We have in the last 15 years, our congressional representatives in Washington have been asking, what's the value of a 4-year degree? What's the value of da 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 da, what we're doing in education? Okay, okay. I don't see any. Oh, here we go. Um, you want to read this one, Erdell? You want to go ahead?
yeah, I think it's important to start introducing AI to students at a young age because it can foster AI literacy and to understand its capabilities and limitations. Yes, one of the big things that we see right now is a lot of students using AI. We are actually thinking through the process of what we're actually doing. And so what happens is students will often put a question into AI and then say solve. And most of the time, the AIs have now been created so that they actually give us all the steps. But all they do is just pull that answer from there. One of the basic capabilities of these things right here is that these things are meant to be chats or discussions. So when you put an answer in and you get an answer, you can challenge the AI. You can go back and say, hey, why did you do this step? Or I don't understand this step, right? And it's one of the things that we don't see students doing right now. We just say, put it in. Oh, I got an answer. Let me just memorize these steps and then try and go forward. When there's so much more learning that we can do.
Can I add to this also, Erdell?
Go ahead.
Yeah, what I really, what, I always like to go above, what we call the meta level, okay? And I really appreciated what you pointed out in your slides. You showed how to build up critical thinking using AI. You you showed collaboration using as you're building this curriculum in AI. Creativity was obvious, okay. Uh, Critical thinking, as I pointed out, critical skills, uh, creativity, collaboration, communication. You also mentioned ethics. Do you know this is what that we call the ethos of the liberal arts, and this is what we hope a university education students graduating with a university educations walk away with. There's been a lot of discussion about using Gen AI, and you'll take over, you'll lose the creativity, you'll lose the critical thinking, all of that. But on the other hand, what you've shown within the slides is you're building it up. So this is an important question. We don't want our students to graduate from university without these critical thinking, without these 4 or 5 C's, emotional intelligence, ethics, which could be done away with if we don't understand the basics of AI and how AI is bringing it up. You pointed that out well in your slides. There's some more comments. You want to read them, Erdell? We can get into this.
Uh, all right. Yeah. So they're pretty close. I kind of read them together. It is important, look at number one right here, because AI is becoming more relevant and integrated into education and daily operation. It is important for students to navigate this through early so they can be knowledgeable. Uh, Lawrence says it's extremely important as AI only continues to advance day by day. It is something that can't be ignored in today's society, meaning the best possible decision is to capitalize on it. Yes, literally, my son is in the fourth grade, and literally one of his favorite things to tell me is to ask AI. And so you got to roll your eyes, and then you also got the Siri, to ask Siri answers the questions and all these things for him. And it's so important to get them to not just simply think about, hey, I can get an answer, as opposed to, hey, I can get an explanation, but also understanding how ethical it is. That's one thing I'm trying to teach him right here is, look, hey, you might be able to get the answer, write that answer down, but are you really learning? Are you really going through the process so that you can later on during your class actually reproduce this information and get those questions right? Uh, and so it's so important, right, to recognize that what fourth grader is already exposed, knows about these things already. We can't just simply let them just say, okay, use it in this one small area and not recognize the bigger, grander vision of how we can use these things to truly help them educate themselves. One of the big things I think is that the third one right here, we have to start recognizing that AI is not just a calculator. It is actually something more. Um, you know, throughout our history, we've had different technologies. For example, when the TV came around, a lot of people thought that TV would simply displace the radio. Um, or when the calculator came about, it kind of it would displace the need for students to actually do mental calculations and that kind of thing. And the answer turned out that no, it was not. Although these tools were very efficient, and for example, if you want to find the sign of 0.7825, you can just type it in and get the answer immediately. You try and do it in your head. Take you quite a while to do it by hand. Um, but the idea right here, artificial intelligence, is not simply just another calculator. It is not simply, hey, can you write me a paper about X, Y, and Z and get your paper and then just go turn that in. No, artificial intelligence is going to allow us to solve a lot of complex problems that we couldn't solve before in the health field, in engineering field, in chemistry, in physics, um, in mathematics, literally all of those fields right now, artificial intelligence is not simply a companion tool that say, hey, do this calculation for me quickly. It is a tool that can actually solve problems that humanly was not possible before. I think on 60 Minutes, there was this one example of they were doing brain surgery to pull out some to a tissue sample to see if it was cancerous or not. And in the past, it was a very difficult process. They would have to go in, do the surgery, pull the sample out, send the sample to a lab. 2 weeks later, 2 or 3 weeks later, they'll get the results back. And if it was cancerous, then they would have to go back in to try to take steps to solve the problem. And in that case in particular, it's a very aggressive cancer. And so 2 weeks might not sound like a lot, but it was a huge amount of time for the patient. And now with the artificial intelligence, literally they get the sample, they have the machine in the room, they give the sample to the machine, and within 20 seconds, the machine will come back, yay and nay, if it was cancerous or not. And then they could just immediately, if it was cancerous, just go ahead and do the surgery immediately. And so literally, it's a game changer in terms of that whole process right there. And there's so many areas in life that artificial intelligence is stepping up that it's not a calculator. As we're running down on time, any more statements about our questions here? Oh, one other thing. Um, I do think that we do need a new citation methodology for artificial intelligence tools. Um, the tools are used differently from our previous knowledge and understanding of citation. The idea behind a citation is someone else's work. And so what happens is you might read an idea from a person, you want to introduce that in a paper, So you have that idea in there, and then you put in quick parentheses. I got this from XYZ paper, whatever year it was, and then that's that. But for artificial intelligence, that's not how it works. The first and foremost, we have no idea whose idea it really was, because literally they pulled every single website on the planet, and they took all the information and they threw it to this model. And so you really don't know whose idea that the machine is pulling from to give you an answer. But secondly, it's still not your idea because the machine is giving you this information. But thirdly, how do we reproduce that answer? If you say, hey, X, Y, and Z machine, please tell me how to solve this problem. And then tomorrow when you come back and you say, give it exactly the same problem, you're not guaranteed to get the same answer. All right. And so what do we cite? When do we cite it? How much do we cite? Um, what kind of answers really don't need a citation because they're whether or not they're common knowledge or whether or not understood that what the AI machine will produce. We do need to think about how I'm actually going to be citing these tools. How do we distinguish between okay, I use this tool to help me come up with a topic sentence, but I wrote the rest of it. How we use these tools to how we navigate students' interaction with these tools. Again, this is really important in terms of the ethics, in terms of trying to help students do all their own critical thinking, trying students to create a process of tracking their use and not simply blindly just typing into the machine. Trying to be more critical about how they think and how they use these things. All right. So next step, conclusions. Teaching the fundamentals of artificial intelligence is critical, even in the middle school. And we have to have a way to develop a modern curriculum that will reflect the new artificial intelligence norm, but reflects the level at the student of the student, but also reflects the needs of the teachers and society in trying to maintain and answering the question, does the student truly understand this knowledge? And then later on, will the student be able to apply this knowledge that they have? Next step, certainly want to expand the curriculum to other grades and maybe push all the way to the top, show all of this material to maybe some of those gatekeepers and some of the legislatures to see if we can start a dialogue on how do we put this into our curriculum. We want to do professional development for teachers, right, on artificial intelligence, ethics, design. And then we want to continue research on how to prepare students for an AI-driven workforce. Literally, what we thought was true about artificial intelligence in the next 5 years may not be true at all. And so we do need to have a continual process of updating as we go through this time of upheaval, as we go through this time of change. Any questions? Yeah, I was wondering what to put at this point right here because AI did help me create this presentation. Uh, I was wondering, like I was saying, how do I exactly cite that part of the presentation? So,
Yeah, Dr. Maurice, I wonder how students are reacting on this. What is their attitude when you try to teach them those tools?
so we haven't had that opportunity to get feedback from students
Okay.
yet on this method. I was hoping to have teachers do it this semester, but all of them declined because of their schedule.
Uh,
But um, from my experience in my classroom, because I try to use a little bit in my classes, students generally are enthused about using these tools and these materials. Um, and I also know at home students use them all the time with those materials. The real issue right here is me just trying to encourage and teach them how to use it ethically.
Yeah.
For example, in my so again my syllabus, I'm going to be including an AI um set of rules. I think I got it from Carlos, right? And so basically, he talked about that you have three different regions. Certain assignments you can use
Mm.
AI without restrictions. Some assignments you can use but with restrictions, and then some assignments you're not allowed to use AI at all. But also, I want to push and encourage students to use AI to question and to think through processes. So, for example, I'm developing a homework assignment where students work problems out, and then after they work them out, they would go and they would put those same questions into AI and prompt and get the results, and then have them make comparisons between what they did and what the AI did. I try to question the relevance of their results and the relevance of the AI results.
Okay. Wonderful. It looks any other comments? Appreciate the comments coming from the participants. Any other comments? Really, I want to thank you, Erdell. A great job. Oh, wait a minute. I see something in the chat here.
It's just a no, if it's modified.
Okay.
No, no more comments.
Okay. Anyway, thank you very much. This is really a fundamental presentation, I should say, because it really is showing the way we need to do this. And it's, like I said, I hope what we do here at Florida A&M's Developmental Research School will be picked up and replicated at other places across the country. So, wonderful job. And I want to thank the participants for coming. And if there are no further questions, then thank you all and look forward to seeing you again next week when we have another presentation from I think it's one of our students next week. Is that right, Erdell?
I
Oh,
believe so.
uh-huh. And and then this Wednesday, we have the Gen AI continuation intro to Gen AI course at 4 p.m. And I think Dr. Jinwei Liu is speaking. Is that right, Erdell? That's
That is correct.
okay. So
Oh,
thank
here
you
you go.
all. Oh, there you go. There it is.
Take a
Uh,
screenshot of the meeting ID.
uh-huh. There you go. So wonderful. Thank you all. Oh, by the way, there is a website. We have the data science, artificial intelligence, machine learning, research and learning cluster has a website. Can you show them that website? Do you have it? Uh,
Um,
where all of our presentations are housed. Also, the recordings of these presentations are there. The slides are there. It's a repository for everything that we're doing with the Monday presentations and the Wednesday presentations, besides the research that's going on by members of the cluster. Let me see. Uh, let,
hold up. I
you,
have the
you have it. You can show them. You know, the one I sent out this morning has it on the slide. Do you have the one that I sent out this morning?
I have I have the back end open right now. I'm trying to.
Right.
I guess I could show on the back end. Yeah, it's actually pretty interesting to see. I think. So yeah, so it is on this website
There
called
you are.
Lovable,
Uh,
and
yeah.
literally to develop this website, you just need to just come in here and then type what you wanted to do, and then it'll do it for you. So here's an example of one of the workshops. Uh, Let me see if I can get the website so I can put the website in the chat for everybody.
Oh, that would be great. Yeah. And so this website's open to everybody. You'll see members of the cluster. You'll see their presentations, their videos, um, the recordings, the research that we're doing. It's a tremendous repository, and also will be a collaboratory. It's a wonderful.
Yes, I put the link in the chat.
Okay, thank you all.
This is the full
Okay.
website right here.
And by the way, we'd love to see your feedback on the website. Please give us your feedback. Okay. So,
Mhm.
yeah, that chart, the graphic from the Viterbi School, that says a lot for everybody. Gives you what the impact of data science and AI and machine learning is. Okay. So thank you, everybody. Uh, I hope to see you all next week, also, and Wednesday for our other presentations. Thank
Thank
you.
you. Take care.
Take care, everybody. Bye now.